Before we go on to the next example, I thought it might be worth at least discussing. I think I talked about how to prove this one, but I didn't say anything about how to prove the others. But if you just generally let u equal a particular vector, u1, u2, and v be v1, v2, and w be w1, w2, or if you want to do it in three-dimensional, if you want to do it in r cubed, then you can let u equal u1, u2, u3, and v equal v1, v2, v3, and w equal w1, w2, w3. And then this proof is direct. Just do the algebra on this side of the equation, do the algebra on that side of the equation. It'll be, it should come out to be the same. Same story with this one, same story actually with all three of these, right? And if, well, 0, 0 dotted whatever v is going to be 0 times v1 plus 0 times v2, or maybe even plus 0 times v3, but that's still going to get to be 0, so that's kind of an obvious one. This is something that's very useful when you dot a vector with itself. It comes out to be the length of the vector squared. If you think about it, if vector v is in two-dimensional space v1, v2, then v1 dot itself is v1 times v1 plus v2 times v2, rather. I'll say it again. v1, or v dot v is v1 times v1 plus v2 times v2. In other words, v1 squared plus v2 squared, which is the square of the length of the vector v, because the length of the vector v would be the square root of v1 squared plus v2 squared. When you square a square root, you drop the radical. So I thought I'd mention something about the rest of those as well. Okay, here's another form for the definition of dot product, where theta is the angle between u and v. Then u dot v is the length of u times the length of v times the cosine of the angle between them. This formula can be solved for cosine theta, so just divide both sides by these two lengths here. So then cosine of theta is u dot v over the length of u times the length of v. And I don't know if you see what that gives us, but that gives us a way that given vector u and v, we can now find the cosine of the angle between u and v, and hence we can actually therefore, with the dot product, find the angle between the vectors u and v just by using inverse cosine. Couple questions. What would the angle between the vectors be if u dot v was equal to 0? Well, if u dot v was 0, then cosine of theta would be 0, so theta would have to be pi over 2. It's a 90-degree angle. If two vectors dot product is equal to 0, then they're perpendicular. Sorry. What does it mean if u dot v is positive? Well, if you think about the cosine of theta, if the cosine, of course, the length of u and the length of v, they're positive numbers. So if u dot v is positive, then cosine of theta is a positive number. That means theta would be in quadrant 1, and it would be therefore an acute angle. So if u dot v is positive, then the angle is less than 90 degrees. And if u dot v is negative, then the angle is between 90 degrees and 180 degrees. Or maybe I should say it like this. If u dot v is 0, then the angle between u and v is pi over 2. If u dot v is positive, then theta is between 0 and pi over 2. If u dot v is negative, then theta is between pi over 2 and pi.